The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and software test professionals, welcome to this webinar on specialization. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services to companies that are looking to improve their test and quality assurance practices. I'm the author of 12 books on software testing, including the bestseller Managing the Testing Process and 4 books on the ISTQB program. We are presenting this webinar in partnership with Software Test Professionals. Check out their website, www.softwaretestpro.com. And come see me at STPCon, their upcoming conference in Denver. Attendance at today's webinar earns PMI PDUs. Thank you to Vicki Sasser for reviewing the materials for PDU status and making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Start the presentation, a couple of housekeeping notes. If you have any questions at any point, feel free to submit them at any time via your webinar interface, but note that they are only answered at the end. You do not need to ask for presentation copies. The presentation is on the web at www.rbcs-us.com on the basic library. By attending this webinar, you are automatically registered for the free e-learning drawing. Check your email over the next couple of days and watch that spam filter. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. So today we will talk about specialization, praise of specialization. And you're probably looking and like going, who is that guy? Karl Marx, what does he have to do with anything? All in good time. So the big hip thing to talk about lately is cross-functional teams. We have cross-functional teams, and hierarchy is not okay. Self-directed teams are okay. Specialization is not okay. And if you read Ken Schwaber, one of his books on Scrum, an otherwise very good book, by the way, it included this statement: you don't have to be a tester to test or a designer to design. And that really sort of got my goat when I read it, because I sort of feel like it's good to be a tester if you're testing, and it's good to be a designer if you're designing, and having expertise and being a specialist is a good and noble thing. Now, I could have just blown the statement off, and probably would have just blown the statement off, except that everybody else is saying similar things with which I disagree. And so I thought, okay, so if the old canard, which seems to be around forever but comes and goes in terms of its prevalence, is now back again, basically anyone can test, how hard can it be, just make sure it works before we ship it. If that story has once again gained even more currency than it often has, time to make a little vocal disagreement about it. So here you have it. So think about baseball if you want a sports metaphor. Okay, we'll paraphrase Schwaber's comment in a baseball setting. So if I said, if you're a baseball player, you don't have to be a pitcher to pitch or a catcher to catch, I mean, would that work? I mean, notice that if you look at any professional baseball team, people generally play specific positions. Now, it's true that in general, everybody's expected to be able to play that position and bat, but some of these positions are very specialized. You might maybe be able to move around in terms of being a baseman or something, but pitching and catching, two very different things. So this, you don't have to be a pitcher to pitch or a catcher to catch kind of thing would make no sense whatsoever in baseball. And I think anybody making a statement like that, in front of professional baseball players would be guffawed at best. Okay, you don't like the sports metaphors, that's all right. I'm not a big fan of professional sports either, but how about professional music? Okay, here we can paraphrase Schwaber again. If you're a musician, you don't have to be a violinist to play violin or a pianist to play piano. I'm pretty sure that with some exceptions, there are some musicians who are good at playing a large number of musical instruments. But I think as a general rule, instruments are reasonably specialized, and certainly there's a fairly significant difference between, say, a wind instrument and a string instrument, a piano versus a violin. Those kind of things are very different types of instruments. Now, obviously, there is some commonality in terms of if you know how to read music, you know how to read music. So there are basic skills which are shared across the different instruments. But, that's true, of course, testing as well. There are basic testing skills that you would want anybody involved in testing to know, including developers doing unit testing, and ideally, if you could ever get them to want to know it, users involved in user acceptance testing. But certainly, you're not a professional pianist unless you're a professional pianist. If you're a professional violinist who happens to be sitting in front of a piano, you are a professional musician who is an amateur piano player. And there's no insult inherent in the word amateur. It's just not what you do for a living. So why does this all matter? Why am I making such a stink out of this? So some people are big fans of Malcolm Gladwell's books. I like them myself. There are other people who really don't like them. He's somehow, for such a nice guy, has managed to be a polarizing figure with his work. I'm not really sure how that goes. But anyway, he has. But whether you like him or don't like him, you might very well be aware that he wrote this book called Outliers. And in that book, he was trying to look at why are people exceptional, what makes for exceptional people. And what he cited was something called the 10,000-hour rule. Now, the 10,000-hour rule gets attributed to Gladwell directly sometimes, but Gladwell actually was citing somebody else's research. And it turns out that this actually goes back a few hops. So there was the paper, this 10,000-hour rule came out of a paper written by a fellow named Anders and a few other co-authors. I forget the name, but don't worry, Google remembers. So if you Google it, you'll find it, or Yahoo it, or however. So in this paper, in the intro, they were basically carrying on some work that was done by another fellow named Bloom. And in the intro of the paper, they make this statement that Bloom's work shows that everybody that he looked at who was an expert, perceived by their peers as an expert, had put a lot of work in. And following on that, they looked at the later studies, following on Bloom's study, showed that, well, guess what? The amount and the quality of the practice are what matter. So our conclusion here, evidence showed that experts are always made and not born. Now, it's probably true that you can be inherently bad at something, and no matter how hard you work at it, you would never be good at it. And it's definitely true that there are limits as to how far you can take certain kinds of knowledge. I know that from personal experience, having run into that very wall in math in my engineering classes. I remember walking out of my last math final, at least it was the calculus series of math, had to do with matrix inversion and so forth, and thinking, thank God I do not have to take the next class in this series, because surely I would fail it and I would never be able to get my engineering degree. So I'm a mathematician or an engineer rather than a mathematician or a scientist for a number of reasons. One being that I just would not make a good mathematician, and the amount of math underlying science at a higher level would be prohibitive to me. So I'm willing to accept that there are there are people who can't be experts who were born that way, born in whatever way, not able to become experts, or at least by the time they started being exposed to the kind of learning that would be required to become an expert, they wouldn't be able to do it. But the other way around here is actually what Bloom and Anders and Gladwell are arguing, is that there is really no such thing as a child prodigy. You might have a ability to grow into something, to learn something, and to master it. But that ability is not by itself talent. That ability is not by itself expertise. That ability has to be honed, and those with an interest will spend the time practicing to hone that ability and will become experts. And in Bloom's work, Anders' paper, Gladwell's book, the point is made over and over again that if you look at any intellectually challenging endeavor, it's going to take you time to master it, and the usual rule is 10,000 hours, which is about 5 years of full-time employment. So, is software testing intellectually challenging? Absolutely, I think so. No, not just anyone can do it. Taking people who have no skill or experience and putting them in senior positions in a test group, or putting them in charge of important things in a test group without recourse to experts is a recipe for disaster. So, yes, I mean, obviously people need to practice to learn, but they need to practice under tutelage. They need to practice in a situation where there are people there to mentor them and teach them. Otherwise, they're going to make a lot of mistakes on the way to their 10,000th hour. Okay, so metaphors, books, research, academic papers, blah, 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 right? Show me the reality. Show me the case studies, okay? So I've got some examples. I've got 3 case studies where a lack of skills, a lack of specialization, a lack of experience were directly, causally related to a disaster of some sort or another. And then I'll give you 3 situations of the opposite is true. The skill, specialization, and experience prevented a disaster, or at least prevented something very unpleasant. So this is not a musing on academic research or pop psychology books, but rather a musing on academic research and pop psychology books, followed by 3 case studies one way and 3 case studies the other way, or 6 case studies total, demonstrating the truth of said pop psychology. And then finally, we'll get at what Karl Marx has to do with all this, and I'm sure that's just torturing you endlessly as I go through this. Okay, so, we'll start with the bad news because, why not? I could end on a high note that way. So we worked on a project, my colleagues and I was managing a testing effort, and there was an interactive voice response server that was one of the core pieces of technology in this system of systems we were developing. And the developers who had created the software that made this thing go, the underlying drivers for the IVR, decided that the way they were going to do their performance testing was to use a technique called cogeneration of load. Now, this has been known to be a bad idea at least as far back as the 1980s, early 1980s, when Boris Beiser wrote his book, Software System Testing and Quality Assurance, where he talked about the risks associated with using cogeneration, because if what you're trying to do is to test for performance and reliability, you need to make sure that the overall load on the underlying hardware is realistic. In this case, the load generators that were running on half of the ports in the piece of equipment, the host for the IVR software, the load generators were very light footprint in terms of memory and CPU. Now, I got a look at what these guys were designing to do this performance testing, and the the developers were allowed to do their own what they called component test, which actually was more like a system test. And I got a look at what they were planning on doing and said, guys, this is really bad. I cited this whole thing on Bizer and cogeneration of load and said, this is not going to be okay. It's not something that's going to work. And they said, oh, well, we know what we're doing. We do this all the time. You just don't understand telephony. So, we're going to go off and do it. Too bad. And I said, well, you can do that however you want your way, but once it comes into my test lab, it's going to get done right. And I think you're going to see that there's going to be a problem. And they said, once again, no, you don't know what you're talking about. Get out of here. You bother me. So they said it was done. We told the project managers, and guess what? It's not done. And it came into system testing, and we then took a load generator, separate host, and hooked it up to the system under test such that every single incoming port was being subjected to load. And it didn't work. Now, it's not just that it didn't work in the sense like it was a lot slower than anybody expected. We started to crank up the load on the thing, and before we got to full load, the system under test crashed, just died, and had to be rebooted. And then so they went through the usual kinds of things of throwing hardware at the problem and memory and so forth, and it never fixed the problem. And ultimately, the project failed in large part because of these basically insoluble scalability issues with the IVR server. And the bottom line here is that this happened because these developers, didn't know what they were doing. They did not understand how to do proper performance testing, and yet they went and did it anyway. And because of that, some bad decisions by 2 or 3 people effectively on a project, 2 or 3 people doing something they really weren't qualified to do, on a project of well over 100 people, that bad decision ended up damning the entire project, collapsing the project pretty much. So, one example. Is an anecdote. But remember that as the statistician's joke goes, the plural of anecdote is data. So here's another anecdote. There was a large, complex project that a client of mine was doing. They are a bank, but they have an insurance arm. And their insurance arm had grown via acquisitions. So they started out relatively small, but with the strength of this relatively large bank relative to the region, they were able to acquire a lot of smaller insurance companies. Now, as those of you who have ever worked in such situations know, acquisition equals proliferation of systems. And so they had this problem where they had a lot of different existing legacy systems, each legacy system supporting the policies of the customers who were customers of the particular insurance company that they had acquired. This is a very common thing. It happens in a lot of situations, and insurance companies suffer from this not infrequently. So I've heard this kind of story about the proliferation of systems and the need to merge all of those policies into a single system from a number of clients. This case, it turned out to be a particular disaster because what happened was the bank was about 2.5 years into this project when they started to have problems. They called me because the problems were manifesting as test problems, and they figured, okay, well, we'll have a test expert come down here and look at it. Now, of course, my usual thinking is that when I get called in to do an assessment because people say, oh, well, there are testing problems or there are quality problems, my usual thought is, yeah, I bet that's just the part you see. I bet the parts underneath the waterline are a lot bigger and don't have much to do with testing. And so sure enough, this is what happened. I get down to Auckland, New Zealand, and I'm digging around, and talking to people in various parts of the organization. And it turns out, the problems are mostly due to performance and reliability issues. And, okay, why are there performance and reliability issues? Well, the database isn't scaling. You dig into that a little further, and it turns out that what they had done was they had this sort of Highlander kind of approach to this merger that they were going to do of these applications. There can be only one. And so they just kind of opened up this free-for-all at the beginning of the project about, let's select which of these applications is going to be the one that survives. So you get people running around advocating for their particular application. And the people who won that argument, it turned out, were these two people. They like to refer to themselves as the designers. One database administrator passed that on to me. He said that these two guys came into the room towards the beginning of the project, and he just said, "Oh, who are you guys?" And they got this very arrogant look on their face, like, "We're the designers." Well, it turns out that these two guys had basically no real database experience. They had built some small access applications, but they'd never done any real substantive database architecture or database design. It wasn't so much that the database wasn't properly denormalized or properly normalized. It's that neither of those two people could have described what normalized versus denormalized meant with respect to a SQL database. They just didn't know. So they had designed this monstrosity, which just would not scale at all. And the thing is, it had worked on small scale kinds of tests, which unfortunately was what these guys had said, just test with this. Well, worked with small scale tests, but once you got bigger and you started having to swap tables in and out of memory, it just collapsed. It just wouldn't work. And so, by the time I've discovered this, it's quite a few $1 million into the project, but there's only so much money left, and there's no time to go back and say, let's start all over again and redesign the system. So what happened was that about a month after I delivered my report saying that was really the only practical way to fix the underlying problems, that is to redesign the database, the organization killed the project. So there were 3 years and hundreds of person years of effort expended on that, all burned up because of the fact that two people who did not have the proper skills to be designers claimed they were designers. So maybe you actually do have to be a designer to design. Maybe it's a really bad idea to take people who are actually not designers and just say, oh, well, these guys have an interest in designing, and why don't we just let them design? Well, this is why you don't let people like that do critical design. And then to use a non-computer example here, you see a picture of the somewhat melted and very sad-looking 777, Asiana Airlines 777. Not only is the airplane, of course, a total waste, but 3 people were killed. Now, to be fair to the pilots, not every fatality was a function of the plane crash itself, right? Though, of course, there would have been no fatalities without the plane crash, but one of the people would certainly have survived the accident were it not for a quote-unquote rescue vehicle running over the individual on the runway, which, that's not much of a rescue. But leaving aside that particular incident, that particular part of the incident, there would have been no fatalities had there not been a crash. Well, why was there a crash? Well, pilot error. Now, I'm always a little bit, I don't know, skeptical isn't the right word, because skeptical means it is doubt. But it's, well, the British expression is, well, they would say that, wouldn't they? Because it's very convenient to say that it was the pilots that did it, right? And so the pilot error, I'm reminded of the situation with the frozen pitot tubes in the Air France flight that, that likewise was blamed on pilot error, but it would have taken actually superhuman piloting capabilities to have recovered from that situation, as was described in the accident reports for that Air France flight. But this Asiana Airlines flight is a different story. It was clearly pilot error. They came in as the reports nailed it fairly early on, too low and too slow, and clipped the seawall on the way to the runway. There's a seawall. If you've never flown into San Francisco Airport, there is a seawall there because you come in fairly low on a fairly low or shallow approach over the bay, San Francisco Bay. At least you often do come in on a shallow approach. Shallow doesn't mean calculated so that your rear landing gear hits the outside of the seawall. And the seawall is what separates the San Francisco Bay from the flat plain, I guess you'd say, of the airport itself, where all of the landing strips are. So the tail of the plane hits the seawall, separates off from the rest of the plane, basically exactly as designed. And that what the back end of it tearing off is preferable to other alternatives like the entire plane disintegrating. Basically, it's taking the shock and dissipating it. But then at that point, of course, the plane is, on its belly, rotating around, and rotated around a few times and came to a stop and caught fire, and, chaos ensued. And in the chaos, there are 3 dead people. So, yep, pilot error in that case, definitely a lot more, definitely a very, very plausible explanation. If you're driving something, airplane, car, go-kart, and it's clear day, and there are no distractions, and you've got the whole runway to yourself, and you run into something, it's probably your fault. So that's what happened here. So if you dig through some of the various online information about the crash, it all kind of comes to the same. Wikipedia had a fairly concise summary of it, and it all says about the same thing, which is basically the pilot and the co-pilot were kind of new to what they were doing. So the co-pilot was new to being an instructor, and he was there to basically advise the pilot on landing the plane. And this guy who was landing it was still in this what they call initial operating experience, which I don't know exactly what that is, but I'm guessing it is exactly what it sounds like. And more importantly, this was his first landing at SFO in a 777. He had landed other planes at SFO before, but not a 777. And, there's reason why you have to get certified on the different planes. Now, it would have been nice if somebody with more experience as an instructor had been in charge of helping this guy know what to do in landing this plane. But because, it was a first for both of them, the first for this Lee Jung-min to be an instructor, and this first for Lee Kang-gook to be the guy landing this 777, his first time landing a 777 at SFO, you obviously create a situation where it's very easy for the pilot to make a mistake, which the instructor, who's not used to being an instructor, doesn't necessarily catch until too late in the game. Now, is it possible that had Lee Jung-min been more experienced as an instructor, could Lee Kang-gook still have made the mistake and and clip the seawall with the tail of the plane. Yeah, I mean, I suppose that's possible. It is, and anytime you're learning something, you are going to make mistakes. And there's a first time for everything for everybody. So I don't begrudge Asiana Airlines, Lee Kang-kook's opportunity to land in 777 for the first time. Something that somebody had to do. Everybody who's ever landed a plane multiple times, there was a first time when they landed the plane, right? And anybody who's ever been an instructor, there was a first time when they were an instructor, but it's probably not a good idea to combine those two first times together when a mistake equals dead people. Okay, so there's three depressing scenarios about insufficient experience and specialization leading to problems. So how about three good examples? So working as a test manager on a project, one of the many different risks to quality that we were worried about was, well, we have these devices that we're going to deploy. They're going to be out in the field, and there's going to be 50,000 of them. And what if all of those things try to connect simultaneously to our servers? What if we can't support them? So, the common wisdom about this is, well, you can't really know until you get everything built, and performance testing is an experimental kind of thing, and you just get it and you start playing around with it and you tune it. And that's common wisdom. It also happens to be common BS, because as previous negative examples showed in a couple cases, that sometimes by the time you discover a significant design flaw that has performance or reliability implications, it's too late to fix it. So rather than just go, well, I'm just going to let this bump get bigger and bigger and bigger, and then eventually, once it's huge, I'm going to check and see if it's cancer. You go, no, let's just not get cancer. So what did we do here? Well, the way that we took it on was first there was a fairly simple spreadsheet model that was built, and it showed for the different types of applications that were going to be running on the different servers how much CPU, memory, and network resource we expected to be consumed based on the number of devices connected simultaneously. That spreadsheet allowed us to eliminate a number of proposed designs as insufficient in terms of their hardware capacity. And then there was a dynamic Monte Carlo simulation of the system behavior built using a tool. There are various capacity planning tools out there. We happen to use a tool called Hyperformix, and that was used to do simulations based on various proposed servers, which further refined the server types that we were looking at and led to yet more refinements in the design of the system. Now, at this point, nothing has been built. Nothing. There is no software. There is no hardware. There is nothing but a design. And a design is basically pictures and documentation describing the way that the server farm might be constructed. And we have already eliminated a number of bad mistakes that we could have made. Now, just parenthetically, I get a little bit irked when I hear people scoffing at big design up front or big upfront design. You hear it called different names, all of them meant disparagingly. Well, I've seen big upfront design or big design up front, whatever you want to call it, done right, as in this case, and it can work. So this idea that brilliant designs just emerge from mediocre designs through refactoring, well, if that were the case, then the two examples that I've discussed previously probably would have been fixable, but they weren't. So, I don't need to go off into a cul-de-sac here, but I think the derision aimed towards big upfront design comes out of a similar mode of thinking as Schwaber's comment about, anyone can design and anyone can test, basically, to paraphrase him. So at this point now, we have a solid design that we have created via this static testing. And at that point, the hardware is now purchased and the software applications are being built. And the critical units that are going to make up these applications that are going to dramatically affect the performance of the system are put through a type of performance testing called profiling, basically checking to see where do we have tight loops and where do we have heavy memory usage and so forth, looking for ways to optimize the behavior of the units before the system is fully constructed. And then finally, we get in a system test, and we're now doing performance testing of the overall system and comparing our performance test results to the simulation results. And, we found some discrepancies. And when we found those, we said, oh, okay, well, then either the simulation is wrong or the expected result is wrong or the implementation has a bug in it, but clearly something's wrong, so let's dig in and find out what the problem is. And we found bugs, and we fixed those bugs. Once we went live, there were no significant performance or load-related problems after release, even as the number of devices attached ramped up. So, this approach worked as just gradually grinding off performance risk down to an acceptable level prior to the end of the project. Now, this line here, we think we should test it first, is something you might have heard before. I hear it from time to time. One memorable occasion, I got a phone call. Actually, it started off as an email via our website saying we want somebody to come in and help us with some test planning. And I'm like, okay. My business partner called and couldn't quite figure out what they were talking about. I mean, yeah, we can come in and we take a look at what you're doing and give you a plan. But it turned out, no, that's actually not what they want. They have a bigger problem than that. And as the guy laid this out, it was like, oh, well, we're about to deploy this system that is going to support an enormous consumer products recall, and we built it, and we know it works functionally. We think it works functionally anyway, but we're not really sure, and we don't know that it'll scale, and so we kind of think we should test it first. And I said, yeah, there's a thought. There is definitely a thought. We can help you do that. So unfortunately, this phone call that I'm describing arrived about 3 weeks before the system was supposed to go live. And this wasn't one of these go live dates like, oh, we'd like to ship on this date. It was more one of these, if we don't ship on this date, the government is going to start fining us, because this recall, this consumer products recall, had been mandated by the government for safety reasons. So we're looking at this deadline. Now, by the time we actually got people on site, it's about 2 weeks from the time they have to go live. We get in there and we look at it and we're like, well, the design is completely wrong, and we're going to have to rework the database because the database design as it currently is will not work. Fortunately, it was a relatively simple database. So there was tweaking, testing, tweaking, testing, tweaking, testing, tweaking, testing. This is definitely not the right way to do this. But in some cases, this can be done. You can, as the cliche goes, pull the bacon out of the fire. And the reason that worked in this particular case is that the people who were working on it had more than 100 years of performance testing experience in total, across the four of them. So we're talking about some very, very experienced people here. Just throwing a handful of people at it who had little or no experience on performance testing and kind of, make sure it works, that probably wouldn't have turned out too well. In fact, I can say that I'm confident it wouldn't have turned out too well, because usually you don't get to do a counterfactual. You don't get to see what happens if you hadn't done something. But in this case, we did get to see the counterfactual, or at least the result of it, because while our client's recall software worked fine in production, The other company that was affected by this massive consumer products recall, I won't mention the name, but it would be very easy for you to find out on the internet if you just look up, burning lithium-ion batteries and battery recalls, etc. And you might even be able to find some of the reporting on how horrible this other company's website was in terms of handling the recall. Now, basically, the way the recall was supposed to work is that people were supposed to be allowed to submit information about the thing that they had and be put in a queue to receive a replacement. Well, the website has to be available for that to work. The website didn't work. Then they had to provide an 800 number to call. But the problem was that the 800 number just connected you to somebody who would try to go in and use the same website through the same service, through the same web server. And so they couldn't get in either. So the shenanigans lasted for weeks on that other company's side, whereas for our client, this went very, very smoothly. So, yeah, usually a good idea to have experienced people test stuff before you put it in production, at least if you care whether it works. And then since I used an air disaster for an example, we'll use the well-known so-called Miracle on the Hudson. So for those of you who don't remember this, there was a U.S. Airways flight leaving out of LaGuardia, and it was on a sort of initial path. Then after takeoff, you're getting up to cruising altitude, but you're still at this point departing the environs of the airport. And unfortunately, at that time, the environs of LaGuardia Airport, being on a wetland, were pretty well populated with Canada geese. And if you've ever seen Canada geese, they're big. If you've never seen Canada geese, think like a turkey, except maybe a little bit bigger than a turkey. They're really big and also able to fly. And in this case, there was a flock of them that sort of came out of nowhere, which will happen if you're flying through an airspace where there's a lot of waterfowl and other birds. It's not possible to see them coming. I can attest to this. Just even driving down the road at 70 or 80 miles an hour, it's often difficult to avoid hitting a bird that jumps up from the side of the road because they don't have the sense to get out of the way. So the airplane, this Airbus 320, flew into this flock of Canada geese, and unfortunately had one or two geese per engine get sucked into the engine. Now they do what are called bird strike tests on airplanes, where they have these enormous air cannons that they shoot chickens out of, and they'll shoot the chickens. I'm talking about like a whole chicken here, obviously dead. They shoot the chicken into the front of the airplane to make sure that it won't burst through the windshield, and they'll shoot the chickens into the running engines and so forth. But there's just limits on how much a running engine can withstand, and in this case, the geese managed to kill the power on the planes, and they couldn't get the plane started again, or couldn't get the engine started again. And so the captain, while they're basically gliding, they're without power. They're gliding. He's trying to figure out, okay, what are we going to do here? They looked at a couple other alternatives. One was flip around and go back to LaGuardia. Nope, not enough speed for that. One was to try to land at Teterboro Airport, which is not that far away, but it's pretty far when you're trying to use a Airbus A320 as a glider. So this guy, the pilot, Sully Sullenberger, told air traffic control, nope, ain't going to happen. We're putting it in the Hudson. And he came in and landed an airplane, an airplane not designed for aquatic landing, in the Hudson without the aid of any power whatsoever. And this is what's even more remarkable. He had no power, so he's flying this thing as a glider. It's not a glider. It's meant to have two enormous jet engines going to provide power for it. The engines are completely dead. It's not designed to land on water, but he manages to land it on water and the flight attendants managed not only to maintain calm during this entire process, but then managed to maintain enough calm that as the airplane is slowly sinking, that they get everybody off of the plane onto the wings and ultimately into rescue craft. And not a single person died, not one. This is absolutely remarkable that in some incident like this, that nobody got killed. And you see this great quote from the Kitty Higgins here, this NTSB board member who was investigating, called it the most successful ditching in aviation history. These people knew what they were supposed to do, and they did it. So, brilliant. And then Sullenberg is asked, he's like an instant hero, and this is a fairly shy guy, but he agrees to go on various interviews. And my favorite comment from all the interview comments that he made was this one here. For 42 years, I've been making small regular deposits in this bank of experience, education, and training. And on January 15, the balance was large enough to make a very large withdrawal. So who do you want flying the plane? You want a guy with a few years experience flying the plane? You want, anybody can be a designer and anybody can be a tester. Maybe the chief's flight attendant should have come up and flown the plane. No, you wanted Sullenberg flying the plane because Sullenberg had all of those years of experience. It matters. And it matters that those years of experience were flying jet planes. If he'd been a helicopter pilot, that wouldn't have worked. If he had been a prop plane pilot, that wouldn't have worked. His experience was as a jet pilot. He had lots of experience doing it. He was a specialist. Now, when I first read that quote from Schwaber, which I've been sort of riffing on and lampooning here the whole time, sorry, Ken, something sounded really familiar about that. And back when I was in college, getting my computer science and engineering degree, we had to get a minor. Now, they didn't really call it a minor in UCLA. I don't know why. It wasn't called minors, but anyway, you had to take something else outside of the School of Engineering, and enough of it to have some sort of cumulative effect, cumulative value, and add it up. So I did economics, but I also took, just as a whim, as an elective, the odd sort of political science class. So I ended up taking on the same quarter or subsequent quarters a class on Soviet command and control economies, and a class on communism, basically with a heavy emphasis on the Cold War. This guy was a sort of history of communism. Now, just to show you what a viejo I am, this was well before the collapse of the Soviet Union. Well, I say well before, it was a good 6 or 7 years before. One of the things that we had to do was read a fair amount of Karl Marx. And so I was like, that Schwaber quote kind of was like, God, I swear I've heard that before. So I went out and looked around, and sure enough, I first thought it had come out of the Communist Manifesto, but it actually didn't come out of the Communist Manifesto. It came out of something else that Karl Marx wrote called The German Ideology, Volume 1, Part 1. So you can imagine, I'm sure there was like a Volume 17, Part 2050, this is the inspiration for Uncle Fidel's endless speeches. But look at what he says here. I think this is interesting, right? So he's talking about distribution of labor. Now, this is one of the things that, the communists weren't happy about with respect to capitalism. As soon as distribution of labor comes into being, everybody has a particular exclusive sphere of activity which is forced upon him and from which he cannot escape. So now he's like stuck being whatever he or she is, a specialist. And in the communist society, oh no, nobody has an exclusive sphere of activity, but can become accomplished in any branch he wishes. Society regulates the general production and thus makes it possible for me to do one thing today and another tomorrow. To be a hunter in the morning, a fisher in the afternoon, a cattleman in the evening, critic after dinner. See, again, the same thing, right? you don't need to specialize. There's no specialization here. There's no special skills actually required to do any of these things, Marx is saying. He's saying that people get forced to do these things over and over again because of that wicked old capitalist system that just makes them do it, forces them to be specialists. Whereas in reality, the human ability is boundless and people should just be allowed to do whatever they want, however they want. And society will take care of regulating the production of goods because, after all, we're just going to have emergent goods, right? They're just going to just pop out of the air, Well, flashback to 1989 and the Berlin Wall, 1989. Turns out that whole Karl Marx kind of idea didn't plan out so well for the many millions of people who were forced to live through that experiment. As you can see, they weren't very happy with it. This is a picture of the Berlin Wall at that point in time. Of course, now there are a few pieces were saved just to remind us what the Berlin Wall looks like. But for the most part, they just hated it and beat it to rubble with sticks, sledgehammers, and poles, and so forth. Excuse me. Okay, so that's kind of an exaggeration. I mean, being opposed to specialization isn't going to be result in gulags or expansionist ideologies or revolutions in Central America or anything like that. I don't think that's. I'm not going to ascribe that degree of danger to these pronouncements, but I do think that a lack of skills and specialization can be a real cause of project disasters, and I've given you some examples of where it has done so, and I'm sure you can think of some yourself. So let's stop belittling specialization. Having good qualified specialists is a common theme in a lot of successful endeavors, including software engineering, and I think it's time that we recognize that while there are a lot of great ideas that have come out of Agile concepts, and many of them, as I say, I'm very fond of. I think there's also some bad ideas. Paraphrasing another famous communist, Mao Zedong, just because a man is a genius doesn't mean that we should assume he has no body odor. So it's okay if there's some bad ideas coming out of what's generally a pool of good ideas, provided that we recognize them as such. So with that, I will, as usual, put up the advertisement and fire up the question and answer panel here, and we'll get to some Q&A. Question via email will start us off. Thanks for the presentation, comrade. Why so critical of Soviet communism? Yours truly, Vladimir P. I think I'll pass on Vladimir's question there. I don't get myself in any more trouble than I probably already am in. Let's see. So David says, are you saying that a tester can only do testing, a developer can only do development? What is wrong in a small team for a tester in a typical siloed role like QA to learn and play multiple roles as the business requires? Okay, I didn't say there was anything wrong with someone learning other roles, and I'm all for testers having a broad set of skills. I think anybody who's read or listened to me talk about skills and so forth over the years knows that I'm a big fan of that, and that we should expand our skills. But what I'm not a fan of, what I think is plain old counterproductive, is to say that skills don't matter. And I think that if that's not what Schwaber meant in that comment that I quoted, then I believe that he should have been a lot more careful in the way that he said it. Because I think if you get his book, and that's just, I don't remember the exact title, but it was one of his earlier books on Scrum. I think if you get his book and you read that statement in context, I think you'll realize that I am not taking him out of context, that the implication there is that these are not specialized areas. And what I'm saying is that they indeed are, that I would not want someone in a development role who wasn't properly qualified to be a developer. Now, obviously, everybody learns by learning. I mean, you learn things over time. You don't just, there's the 10,000 hours that I cited, and those 10,000 hours have to be spent doing that thing. So, yes, there is a place to be learning something, to be a trainee, if you will, a journeyman, however you want to put it. I dislike the phrase journeyman because it makes it sound like what we're doing is a craft, while it is now, it should not be. What my point is here is that you should not have people playing key roles in certain areas if those areas are are intellectually challenging areas, unless they have sufficient skills and experience to be called an expert or a specialist. That's my point. Let's see. Michael was talking about the musicians and baseball players metaphor that I used. He said, your qualifier in each of these scenarios is the term professional or expert. Anyone can pitch, anyone can play the piano, anyone can test software, but to do so professionally takes an expert and specialist. Yes, that is my point. I mean, I can play a violin. Give me a violin. I can make noise come out of that violin. I swear to God, you'll want to beat me to death with that thing after you hear me play it for like 2 minutes. And I can pitch as long as you don't care about the ball getting from the mound to the plate, not to mention over the plate at any sort of speed. I don't have the arm muscle for that, or at least not the arm coordination to do that. Yeah, I mean, it's like anything else that, things can be done by amateurs for sure, but that doesn't mean they're done well. And that's what I'm saying is that if there are things that we want to be done well, then we need to have specialists doing this. The predictable question has come up here. How do I get the slides to print out for this webinar? So what you've got to do is go to the RBCS website, rbcs-us.com, and navigate to the resources tab, and from there navigate to the basic library, and you'll find it there. The recorded version of this webinar will also be posted on the digital library in about a week. That's the usual turnaround time. Let's see. Janet says, there is a lot lost when there are no checks and balances with different people testing. There is also a lot lost when there are not people specializing in test practices too. Yeah, right. I mean, I think so. So I'm not saying, I don't want this to be construed as saying that testers should not or developers should not unit test their code, or that users should not be involved in unit testing. And again, I think anybody who's listened to me talk on these topics of skills and team organization and so forth will know that I definitely believe that that should happen. But the primary test value that's going to be added on a project is not going to be added by developers doing unit testing. It's not going to be added by users doing user acceptance testing. It's going to be added by professional testers, or it's not going to be added at all. If you rely on amateurs, on developers and users who are amateur testers in the sense that they are not professional testers, they have no certification, training, or real specialized experience, so they cannot call themselves professional testers, which means they're amateur testers. You're not going to be able to rely on amateur testers to achieve the kind of value out of testing that you would get from professional testers. Testing is a skilled, intellectually challenging field that has its own specialized body of knowledge, and if you rely on a cadre of people without any of them having that body of knowledge, then the team will be deprived of that and the benefits of it. Raza says, props for the Highlander quip. I guess I should have I should have had props of some sort or another. I can running out with a sword or something like that. Yeah, that was an interesting project, that's for sure. Donna says that she lost audio but then got it back. Sorry about that. That does happen. Usually it's, from what I can tell, it's a user side connectivity, internet connectivity issue, though I think it probably could also be a Citrix server load issue as well. But in the case of it being a Citrix server load issue or a connectivity issue on our side, it's likely that everybody would lose audio at the same time, and I'd get a lot more complaints about that. Let's see. Michael says, just like Toyota's recall of cars automatically accelerating, right? I'm afraid I'm not able to really put that in context, Michael. Maybe you could resubmit that question with a little more context of what you were juxtaposing that against. Travis says, in markets where there aren't enough experienced applicants for testing positions, do you hire somebody who has multiple years of experience in more than one skill set, for example, project management, business analysis, and software testing? Or do you not hire anyone until the perfect candidate comes along? Someone with this type of background could be a valuable asset and can be trained to be a test specialist. Your thoughts? I agree. Absolutely. I mean, everybody's got to start somewhere. And I have hired people with a wide variety of backgrounds to come in and be entry-level folks in test teams. People with project management experience, people with business experience, business analysts, people with military background. I've had a lot of luck with hiring folks who were retired military and were looking to kind of get into high tech. There are a lot of different skills out there that can provide a useful foundation for understanding the general ideas of testing. And also, of course, you don't want to underestimate just the importance of general professionalism in being a good tester. So that's valuable. But I guess my point there would be not that these people can't be hired, because of course they have to be hired. Everybody has their first day as a tester. I had a first day as a tester. You had a first day as a tester. Travis, everybody had a first day as a tester, and none of us were experts on that first day. But the important thing is that there be sufficient mentoring and guidance and training available to bring that person to their 10,000th hour when they actually are an expert. And that's what I'm advocating here, is that there be this idea of specialization, that there be this idea of a career ladder, and that people progress to a level of competence and capability, rather than this just sort of assumption that there's no real specialized skill there, and anyone can be assigned to do testing, which was again the inherent in the way I read Schwaber's comment. And I think also if you go and you read it out of his book, I suspect you'll agree with me that I'm not taking that quote out of context. Unifia says, thanks for the session. You're quite welcome. Let's see. Ahmadressa says, please introduce me a good book about the concept of testing. Okay, well, if you are entering testing, I've got a couple books that I've written that I think could be useful to you. If you're interested in a foundation type of, or the ISTQB Foundation and certification, then the Foundations of Software Testing, I think, would be a useful resource to you. If you're not interested in the certification track, then I wrote a book called Pragmatic Software Testing that it could be useful. If you are more of a manager type and not so interested in certification, then Managing the Testing Process would be a good one for you. If you are at a more advanced level in your career and looking for books on software testing that are relevant to the ISTQB program, I have the advanced software testing series that you could take a look at. Janet says, our organization is moving towards the anyone can test attitude. They seem to think it's going to be more economical and save them people hours. Are there any statistics to back up that it doesn't save time? Yes. There is a study which is cited in Tom DeMarco and Tim Lister's book, Peopleware, where it says that the difference between the most qualified and the least qualified person carrying out a task is going to be a factor of 10. So and that's cited fairly early in the book. So what that would say here is if they took all of your experienced, skilled, expert testers and replaced them with the anybody could test testers, that it will basically take those anybody can test testers 10 times as long to do an equivalent work, and in the meantime they'll do it 10 times worse. So they'll find a lot fewer bugs, and it'll take them a lot longer to do it. They'll provide a lot less risk mitigation, and it'll take them a lot longer to do it. They'll provide a lot less information and maybe even no information, and it'll take them a long time to do it. And the resulting level of confidence at the end of their escapades will probably be close to zero. So, yeah, take a look at that study by DeMarco and Lister that they cite there in that book, and that should give you some ammo for this. I mean, there are ways of structuring test teams around a few experts supervising a fairly significant number of non-experts, but it's all pretty much a kludge to try to get around a situation that ideally you'd avoid by just hiring really qualified testers. Okay, this is interesting here. Raza started off. I seem like I've hit a nerve with my comments about Comrade Marx. Raza says it's the capitalist plutocracy that says everyone needs to retrain. Little to no vac, and then sorry darn enter key. And I don't see the rest of the comment, Raza. I'm interested to see it though. So now you've now piqued my interest, and the capitalist plutocracy is always a good way to start off a comment. If you want to get a libertarian like me fired up. Let's see. Ovidio says, do you think that the specialization makes that a product orientation to be better than project orientation? So I think if I'm interpreting this question right, is it more important to understand the business and the business domain and the problem being solved by the software than the technology being used to implement the software? If that's the right way to interpret product orientation over project orientation, and I would say neither. I would not recommend either one or the other without a study of the specific situation. So here's why I say that. So I have a client that does oil exploration software, geological modeling software from the oil business. They will only hire people with college degrees in relevant fields such as petroleum engineering, chemical engineering, those kinds of things. Somebody could have 30 years of test experience, go to get a job with them as a tester, like, nope, not going to do it. Similarly, you could have 10 years of programming experience, just general programming experience, not oil industry related. They would say, no, I'm not going to hire you. As he explained to me, he said, I can teach them what they need to know about the technology, and I can teach them what they need to know about testing, but I cannot teach them in the time available enough about the oil business for them to do this job right. So see, for his particular situation, domain knowledge was the thing. That was the specialty that was needed. Now, I've worked with other clients where the specialty that was needed, at least for certain fields or certain areas in the team, was testing specialty. So teams that had performance, reliability, and automation groups, where domain knowledge and understanding of the technology as it relates to construction of the system was not as important as the knowledge of how to do testing using those tools. Now, of course, if you know how to use automated tools, you also tend to be very strong technologically because there's a synergy between programming knowledge and knowledge of the tools. But, definitely the focus there is more on testing. And I've also worked with clients where the technology was sufficiently complex that the need was for technological knowledge. So I've done, I'm sure I have done a webinar on this in the past about how to determine the appropriate skills for a testing group and then to manage the skills of that group in an appropriate way. So take a look at the recorded webinars, and I think you'll find more information about that. If for some reason I have not done a webinar on that and you can't find one, send me an email as a suggested webinar topic, and that's something I can pick up and cover pretty quickly. Let's see. Video comments. I'm from Romania, which from your last name, I guess that you were. And I will actually be in Romania in September. I will be in Bucharest at the C-Test conference in Bucharest. So, video, maybe I will see you there. Maybe you can stop by and say hello, and we can talk further. Akmandreza says, thank you. You are welcome. Brittany asks, do you think developers and testers should work together on testing if the testers are not specialized in one area? I would certainly like to see developers, testers, and business stakeholders work collaboratively on everything that they do on a project, that they be available to each other to share knowledge, answer questions, ask questions, work together in a collaborative, close fashion. I think that's very important. Can people fill in each other's skills gaps by doing this? Absolutely, through cross-training and mentoring. Yeah, and I definitely am not saying there should be an iron wall put up between developers and testers because nothing a developer knows is of any relevance to a tester or vice versa. I mean, that's that to make such a statement would be completely asinine, and that's not what I'm saying. But what I'm saying is, let's identify skills gaps that would exist in people on our projects, regardless of what role they're in, and then identify people who have those skills, regardless of what role those people are in, and figure out ways of doing that kind of cross-training and mentoring. I think that's a good idea without a doubt, and it should not be, the testers can't ask the developers anything, and the developers can't ask the testers anything. That doesn't make any sense. So thank you, Brittany, for the opportunity to explain my point there if I perhaps confused people earlier. Raza says, our value should increase with experience and focused training, but automation appears to be pushing the human worker out. Comment on the conflict of specialization and its conflict with corporate profit margins. Think Amazon and Walmart. The context of ageism and firing people when they start earning too much, maybe out of scope. Boy. Okay, well, I guess it's fair enough to say that since I took a stick to Karl Marx and started beating communism like a piñata, that I should have to defend capitalism a little bit. So here's what I would say, that capitalism is obviously not a perfect system, and I was not beating up communism to say that capitalism is perfect. I mean, capitalism is obviously a amoral system. By that, I don't mean immoral. I mean amoral, in the sense that capitalism is about maximizing the return on assets and return on equity. And when that becomes the priority, obviously there can be human collateral damage to that. And when a choice leads to more money for the people who have the capital, but less jobs, less opportunities, and so forth for other people. But then the question is, what other alternative has ever been proposed in history that has done as good a job at maximizing human freedom, happiness, and prosperity? I don't think you can point to one. So, yeah, that's kind of a political digression, I guess, a little bit, but I really do think while there is obviously a necessity for governments to curb the excesses of its citizens, both individual and corporate, I think we can see from the evidence of what happened in 1917 through 1991, that idea of curbing the excesses of individuals and corporations can go way too far. Now, does that mean that I would hope does that not mean that I don't hope that people would value specialized, skilled people and look at people in their 40s, 50s, and 60s and say, there is a specialist, there is an expert, there is somebody who I need to keep around? No, and I think that it's actually short-sighted and not very true to the spirit of maximizing return on investment if we say that what organizations have done over the years is invest in human capital. Certainly in software engineering is the most important kind of capital there is, and it's likely to remain that way for at least the next 50 to 100 years. Organizations have invested in this human capital, making people skilled, experienced experts, Sullenbergers of software, basically able to land a plane in the Hudson if they need to. And when companies turn people like that out on the streets, they're making a big mistake, I think. And so I tend to agree with DeMarco and Lister on that turnover and loss of skilled and experienced people is a stupid thing that companies do that actually is bad for the bottom line. So enough digressions on capitalism, communism, ageism, etc. Pamela says, not a question, but an example. Good example of specialization is general aviators being required to fly the Osprey aircraft fixed wing to rotor. United States Marine Corps had to discontinue the Osprey because it requires highly specialized skills, so only specific pilots could fly it. Osprey is an amazing aircraft. Yeah, that is a good example. That's an amazing aircraft in the right people's hands, but in the wrong people's hands, it was not. It wasn't something that could be used real easily. Yeah, and then there are other examples of that in aviation too. The Concorde, the cockpit controls of the Concorde were so complicated that it is just overwhelming. And I think it's Jakob Nielsen's book on usability engineering gave the cockpit of the Concorde as like, don't do this. And you look at this, he shows a picture of it, and it's just gauges and dials and levers and stuff everywhere, and there's this teeny slit that you're looking out. It's very little awareness of what's going on around you, and very difficult plane to fly, and not No, you don't want the system to be so complex that it overwhelms the ability of someone to do it. But that's getting off into usability. But certainly there is a certain level of inherent complexity in everything, including tasks like software testing. And if you have people that do not have the skills to deal with that inherent complexity, they're going to make a higher number of mistakes. So I think that is relevant. Thanks, Pamela. Video says, right on the subject point, thanks very much for the feedback. I'm waiting to hear by on the conference in Bucharest from September. Yeah, go out to CTest, SEETEST.org. See, like to see something with your eyes, test.org, and you can find the details of the conference in Bucharest, and come see me there. If you still can't figure that out, can't find the website, send an email to info@rbcs-us.com, and we'll let you know. I'm also going to be in Budapest later this year. In October, I'll be at the HUSTEF conference, HUSTEF. I think it's HUSTEF.org is the website, but just do a web search for HUSTEF conference in Budapest, and you'll find me. So I'll be there giving a talk. So for my European friends and colleagues, if you're able to attend either of those events, that'd be great. I'm also going to be at a event in January in Austria, in Vienna. So I'll be able to see those of you who are on the western side of the European continent there. It's mid to late January. I'll be there, and then I'm going to be back in Budapest in January doing some training courses, including an Agile course and an expert test manager course. So if you want to catch me in Europe, I've got a few dates there over the next 6 months, and it'd be great to see some of you there. For those of you who are in Europe, those of you not in Europe. So, for example, in Malaysia, I possibly be down in Malaysia at the end of September. I'm hoping so. Crossing my fingers for that because I always love going to Malaysia. So those are sort of my foreign adventures upcoming. Other than that, I'm mostly in the United States the next few months. Ahmed Dressa says, I was from Iran, and thank you for the webinar. You're quite welcome. You say you were from Iran. I'm assuming you're not in Iran right now, but perhaps you could be. I didn't realize that we were had listeners out there, but if so, welcome. Leslie says, cheers from a fellow libertarian. The examples you used up front around the baseball team and the musicians were excellent. One could also make a similar claim around doctors and nurses. Yes, absolutely. That being said, do you think management tends to feel that skills like testing aren't as technical as they are? I had a manager tell me once a trained monkey could be a tester. Oh, geez. Trained monkey. Excuse me. I think I've worked for some project managers that were actually probably trained monkeys based on some of the decisions that they made on those projects. Yeah, I think there's just a general sense that testing doesn't require the level of skill that it actually does. And so I think there's a number of things that feed this, Leslie, and I could go off into this huge digression on this, but I won't since I've already used my digression card once on the whole libertarian thing. I think part of the problem is that organizations often do just have anybody test. And so their experience is working in places where just anybody tested. And they come away with that thinking, well, that's just the way it's done. And the analogy I always use for this kind of thing is, back in like the 1700s, early 1800s or so, people would have these enormous families. You'd have like 10 kids, 13 kids, Why? Well, because a lot of them just died before they made it to full adulthood. They would die in their, in infancy, they'd die as young children. They would die as teenagers. They'd die as in their 20s, before they got a chance to have a productive life and have their own kids, right? And just the simplest things could kill you. You get a scratch, the scratch gets infected. There's no antibiotics. You get an infection, the infection goes systemic, boom, you're dead, And it's just like, oh, well, that's the way life is. And I think that's kind of the way that some people are about testing. It's like testing is done incompetently and projects die or projects have serious quality problems. People are like, oh, well, that's just the way it is. Like, well, no, it doesn't have to be that way. But the number of real skilled expert professional testers out there doing skilled expert professional testing is still too small a number. And so not enough people have seen it done right yet to know what the difference is between done poorly and done right. So I think that's part of the problem. I think another problem too is that there are some bad ideas floating around out there from again, people, otherwise skilled people saying things that encourage certain behaviors that are not productive. Okay, so here I'm talking about that whole process cop mentality where testers run around try to tell other people what best practices are in fields other than theirs. Usually not helpful. The quality cop mentality where people are like, well, I should be able to stop a release, or just the people who get confused about the difference between having integrity and being a jerk, and then they don't realize that there is actually a difference there, and you get this jerky, argumentative, contrary, beside the point kind of behavior cropping up. And so I think just there's just sort of this general bad stereotypes about testers, which are reinforced by occasional people who behave that way, that our process cops, quality cops, are just plain jackasses, and a lack of competence. So it's important that for those of us who are professional testers, that we really work at doing this right and serving the missions that we're actually there to serve, and being pleasant and productive members of the team, even when we're delivering bad news. I think it's a matter of educating. There's a lot of educating that we have to do. Let's see. Raza says, Rex, I'm not defending communism. My comments are inspired more by Aubrey de Grey's views on the imminent demise of the middle class in the West and the work being done to increase productive longevity. Great inflation and short-term thinking are pandemic, and technology is an enabler. Sorry for the digression. Thanks for yet another interesting webinar. Okay, I have to admit, I know everybody who's anybody has read this book by Aubrey de Grey, but I have not. And I've heard people talk about it and say it's a really interesting book and you should read it, and I probably will get around to it someday. But yeah, I'm aware of that argument out there that, and some people have interpreted that as as de Grey saying Marx was right, but I know that's a simplistic way of looking at it. So anyway, thanks for clarifying that you were citing de Grey rather than Marx or Lenin. And yeah, someday I will get around to that book. Leslie has a follow-up here. Making the case that testers aren't easily replaceable is the biggest challenge. Corporation I used to work for tried to form a testing team, pick bad people without the proper training and rigor. Having new people without a 10,000-hour expert leading, without a systemic environment, leads to the trained monkey mentality. Yep, absolutely. Yeah, and then, people see the outcome of that, and rather than going, that's not the appropriate way to organize a test team, the conclusion is, oh, well, anybody could do that. Well, yeah, of course. I mean, if you take a band of amateurs together, give them no expert guidance, then observe what they do and come to the conclusion that anybody could do that. Well, yeah, of course. If I gathered a bunch of random 10 to 12-year-old kids out of a schoolyard, threw them a football, split them into two teams and told them to play, and watch for an hour and then said, oh, well, there you go. That's football. I mean, it's just completely absurd, and nobody would do that. Nobody would accept that. Everybody would see that experiment as completely invalid and meaningless, right? But for some wacky reason, that same exact experiment gets done all the time in software engineering organizations with test teams, and people don't come to the conclusion of, oh, well, this is actually a stupid way of doing it. So someday, maybe, Leslie, we'll have educated people enough that will stop happening. And I think it will. I think it will be the someday. I don't know. I've got maybe 15 years left in this business, and so it might not be gone by the time I'm gone, but I'm hoping to see serious diminution in that that kind of thing before I'm done. And this is why going back to the origins of this, why I got so exercised when I read that comment in Schwaber's book, which is just like, damn, this is a step in the wrong direction. This is a step backwards. It's an influential voice now getting out there and saying that all of this work that's been done in the last 25 years in terms of professionalizing testing is meaningless, and we don't actually need professional testers. So that's why I wanted to have a little webinar temper tantrum about that. And I hope that all of you, if you agree with me, will push back on that too, that idea, there's a lot of great ideas coming out of Agile, that idea is a bad one and needs to be pushed back on. Okay, well, to close this session, a little bit more about the resources available from RBCS. We run these free webinar sessions once a month, so check our website, rbcs-us.com, to sign up. If you'd like a special webinar presentation for your company only of this webinar or on any other topic related to software testing, contact us at info@rbcs-us.com or via our website. If you don't already receive our free regular newsletter, sign up at rbcs-us.com. This will get you valuable discounts on consulting and training services, along with a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can also follow us on Twitter. I'm at RBCS. I also have my own Twitter feed now at Leica Test Dog. That's Leica, like the dog that went to space. We're on Facebook at RBCS-INC. Do remember to check your email over the next couple days. You could be the lucky winner of the free e-learning course from RBCS. You are entered for a random drawing for this course simply by attending this event. Do check out our digital library. We've got recordings of these webinars, podcasts, and videos, including an extensive series on risk-based testing. And you can also subscribe to get these webinars regularly via iTunes or other MP3 services, or subscribe to our RBCS channel on YouTube. We offer these free resources as a service to the software testing community because at RBCS we are a not-just-for-profit company. This concludes the webinar. Thanks for joining us today.